Assalamu alaikum. This is the third class of trigonometric ratios. In the last class, we learned how to find out the unknown sides of any right angle triangle. Now, in this class, we will be learning how to find out the unknown angles of any right angle triangle. Starting with the first question, it says use a calculator to find each of the following angles given its trigonometric ratio sine of x a equals to 0.527. Okay, in order to solve this, what we'll use is we will use the calculator to find out the angle. One thing which you should always remember is that whenever you have sine and after sine you have an alphabet, okay, that alphabet actually represents the angle. Whatever we write after sine, okay, is the angle. Okay, this a represents an angle here, this also represents an acute angle, this also represents an acute angle of a right angle triangle. So sine of a equals to 0.527. In order to solve this with the help of the calculator, 0.527. Okay, so in order to solve it, what you will do is you have to write a is equals to sine inverse of 0.527. Now how will you use the calculator to get this value? You will first press the shift button on the calculator, then you press the sine button, okay, and after the once you will press the sine button, the calculator is going to open a bracket. Okay, the calculator will show you sine inverse and the bracket will open. There you write down this number 0.527. Okay, so you have to actually press three buttons, shift then sine. As soon as you're going to press these two buttons, the calculator is going to show you this much. You will have to input 0.527 here. You don't need to close the bracket if you just have to solve this much only. So press the equals to sign after that, and the calculator is going to give you the angle. So you will write a equals to 31.8 degrees. So this is how we find out the angle. In the b part, it's cos of b equals to 0.725. What we will do is we will press the shift button, then we will press the cos button. As soon as we will press the cross button, the calculator will show us cos inverse and a bracket open. In that you will write down the number 0.725. Okay, so write 0.725 and press an equals to sign, and the calculator is going to show you the answer, which is actually 43.5 degrees, 43.5311. So you round it off up to one decimal place, because we have the rule that every angle up to one decimal place. There's no rule of three significant figures in case of angles. In case of measurements, it's three significant figures. In case of angles and degrees, the answer should be up to one decimal place. So the answer for B will be 43.5 degrees. The C part, it says tan of C is equals to 2.56. So the working which I have to show on my paper when I'm solving it, I will have to write C equals to tan inverse of 2.56, and I will give the answer directly. Tan inverse of 2.56, it's giving me 68.7 degrees. This is the first question done. Then we move on to the second question, where we have to learn how to find out the unknowns in each of the following right angle triangles. It says find the value of the unknown in each of the following right angle triangle. If you notice, in the previous exercise there were unknown sides. Here you will notice unknown angle. We are not given any angle, and we are learning how to find out the angle. Now with reference to this angle, the two sides which are given to us are the opposite and the hypotenuse. This is the opposite side of angle A, and the hypotenuse is given to us, which is 26. Adjacent side is not given, so we will use the ratio which uses opposite and adjacent, and we know it's sine. We will write sine of A equals to opposite side upon the adjacent upon the hypotenuse. We will write sine of A equals to, I'm solving 12 divided by 26, it's giving me 0.462, 461538, so 154 I'm writing. Now in order to get to this, as I told you, whatever is written after sine is an angle. So in order to find out this angle, I will have to write A equals to sine inverse of 0.46154. So I can use my calculator. What will I do in the calculator, because this answer is already there on my screen on the calculator of the calculator. So what I will have to do is I have to press the shift button, I have to press the sine button after that, Once I press the shift and the sign button, the calculator screen is going to show me sine inverse. I will have to write 0.56154, and since it is already stored in the calculator screen, I can just press the answer button. So sine inverse of answer is going to give me the angle. Okay, so sine inverse of answer, I will just have to press the answer button. So it's giving me 27.5 as the final answer, 27.5 degrees. I hope it's clear. Once you solve this answer will be stored in the calculator. You will press the shift button and the sign button. The calculator will show you sine inverse and a bracket open. Then you press the answer button, because this answer is already there in the calculator stored. So shift, sign and answer, and the calculator is going to put this answer directly into this bracket, and you will get the answer for the angle. Okay, I'm starting with the second part now, the B part. The B part, if you notice, this is the angle, the adjacent is known, the hypotenuse is known, so I am going to use cos here. Cos of B is equals to adjacent upon the hypotenuse. In order to solve for B, I will do B equals to cos inverse of 10 upon 17. I can even do it directly. Instead of first finding out 10 upon 17, get the decimal value, and then doing cos inverse of answer, I can directly use what? I will press the shift button, then the cos button, these two buttons, and after that I put the fraction button. I press the fraction button. You must be knowing the fraction button is this button. Okay, press the fraction button and insert 10 upon 17 in this. Okay, so shift, cos, fraction button. In the fraction button, I'm inserting 10 upon 17, and I'm getting the answer 53.96. So it will become 54.0. So B equals to 54.60. Sorry, for 54.0 is the final answer for this angle. Okay, the C part then. With reference to this triangle, I know the opposite and the adjacent, and the ratio which uses opposite and adjacent is actually tan. So I'm going to use tan here. Tan of C equals to 27 upon 11. So C will be tan inverse of 27 upon 11. I am using the calculator. I am pressing shift tan. The calculator screen is showing me tan inverse and a bracket. In the bracket, I am going to write down I will press the fraction sign, which is this sign. In the numerator, I am going to write 27. In the denominator, I will write 11. And the answer is coming out to be, the answer is coming out to be 67.8 with rounding off. Okay, 67.83. So I'm ignoring the 3 up to 1 decimal. This is the answer. The last part, which is the D part. Okay, with reference to this acute angle, I know the adjacent and the hypotenuse, so I'm going to use cos again. Cos of D equals to adjacent, which upon the hypotenuse. So D is going to be cos inverse of 17.6 upon 20. Cos inverse of 17.6 upon 20. This is giving me 28.4 degrees. This is the answer for the last part of the question. So we're done with question number 2, A, B, C and the D part. Now we're doing question number, a few more parts out of these, and then we'll move on to the next exercise. Okay, I'm just doing the F part. In the F part, if you notice, with reference to this angle, I know the opposite is 12.5 and the adjacent is 14. Hypotenuse is not known. We don't know what is the hypotenuse. We need to find out the angles. So using opposite and adjacent, we will be using the ratio, which is tan, because tan is opposite upon adjacent. Tan of F equals to 12.5, which is the opposite side, upon the adjacent side, which is 14. So I will write F equals to tan inverse of 12.5 upon 14. Okay, so tan inverse of 12.5 divided by 14, 41.76. So I will make it into 41.8 degrees. Okay, so I'm doing one more here, which is the last part, which is the I part. With reference to this triangle, if you notice, with reference to this angle, I know the opposite and the hypotenuse. So the ratio which uses opposite and hypotenuse is sine. So I will write sine of I equals to opposite, which is 32.75, upon the hypotenuse, which is 41.62. So I'm doing sine inverse. In the shift with sign, in the bracket I have put the fraction there. In the numerator I am putting 32.75. In the denominator I am putting 41.62. I am getting a 51.8, so I will write I equals to 51.989, so it's 51.9 degrees. I hope it's clear. Moving on to the next level question, which are the intermediate level questions, which are here. So I'm starting with question number 3 now. Okay, here it says the figure shows a quadrilateral ABCD, where ABC equals to angle ABC equals to angle BCD equals to 90 degrees. Given that AB equals to 4 and DA equals to DC equals to 7 centimeters. Okay, you can notice DA and DC both are 7 centimeters. Find angle ADC. You're supposed to find out this angle. Okay, now if I can, because I don't see a right angle triangle here, so I can draw this line. Okay, and now I have a rectangle. I have divided the shape into a triangle, right angle triangle and a rectangle. So if I have to find out this angle of this right angle triangle, I know just one thing, which is the hypotenuse, which is not enough to find out this angle. But I have this data that this side is 4 centimeters and this side is 7 centimeters. So 7 minus 4, because from here till here it's 4. This from here till here it's 4, and the overall thing is 7. So 7 minus 4 is a 3 meters. So this measurement is 3 meters now. Now I know the adjacent and the hypotenuse of this right angle triangle. The ratio which uses adjacent and hypotenuse is cos. So I'm going to write cos of angle ADC equals to adjacent upon hypotenuse, and I'm using angle ADC equals to cos inverse of 3 upon 7. Okay, so I'm using the calculator to get to this. Cos inverse of 3 upon 7. I'm getting 64.6 here. ADC equals to 64.6 meters, because every measurement in this question is in meters. Okay, then they are asking for the length of BC. If you notice that the length of BC is the same as the length of this line. Okay, so if I use this right angle triangle and find out this side. Okay, now I have two ways of doing it. One is Pythagoras theorem, because I have the two sides of a right angle triangle. I can easily find out the third side. Or if you want to use trigonometry, since I already have the angle with me. If you have two sides in a right angle triangle and you want to find out the third side, you have to first find out the angle, which we have already found it out. Without finding out the angle, you cannot find out the third side of a right angle triangle, even if you know the rest of the two sides. You have to use Pythagoras theorem if in case you don't want to use trigonometry. But if you don't want to use Pythagoras theorem, you have to find out the first. You have to first find out one acute angle of the right angle triangle. Once you find out one acute angle of the right angle triangle, then you can easily find out the unknown side. With reference to this acute angle, the opposite side we have to find out, because actually we are supposed to find out BC, but BC is the same as this measurement. So opposite upon adjacent. Okay, I can call this measurement as x here. So I'm writing tan. I can use tan for opposite upon adjacent, because adjacent is also known, or I can use sine. Sine is opposite upon hypotenuse. I can use these two, or I can use these two. So I'm using tan here. Tan of 64.6 equals to x upon 3, and I'm solving for x, which is 3 tan of 64.6. 64.6. 3 tan of 64.6, which is 6.32. So x is 6.32 meters. This is 6.32 meters. So x is the same as BC. Okay, so I can write BC is 6.32 meters. This is the answer for the second part of the question. Okay, then we move on to the next question, which is question number 4. It says in triangle LMN, LM is 15.5 and LNM is 90 degrees. H lies on NL such that HM equals to 9.2 centimeters, and HMN equals to 38 degrees. They're talking about this angle. HMN is 38 degrees. Find MLN, the angle MLN they are talking about. So MLN is this angle. You have to find out this angle. This angle. Okay, if you look at this, this is not a right angle triangle, so we cannot apply sine, cos and tan on this. Okay, so we have to use something else to find out this angle. Now if you look at the whole big right angle triangle, I don't have this side, I don't have this side, but I can easily find out this side with the help of this right angle, the smaller right angle triangle. If I consider this right angle triangle, I have one angle in one side. As I told you before as well, if you have one angle in one side, you can easily find out the other rest of the unknown sides of the triangle. Okay, so I'm using cos here. Cos of 38 is nm upon hypotenuse, adjacent upon hypotenuse. So I'm using cos of 38 degrees equals to nm upon 9.2. So nm will turn out to be 9.2 cos of 38. 9.2 cos of 38. It's coming out to be 7.25. nm is 7.25 centimeters. So I'm writing 7.25 centimeters here. Now once I have this side, which is the hypotenuse, I'm talking about the whole big right angle triangle. Okay, talking about the whole big triangle. Okay, if I have to find out this part MLN, which is this angle, if I have to find out this angle, I know the opposite. Okay, and I know the hypotenuse. So opposite upon hypotenuse is sine. So I'm going to use sine with this. I'm going to write here sine of MLN equals to opposite, which is 7.25, and hypotenuse, which is 15.5. So MLN would be sine inverse of 7.25 upon 15.5. It's coming out to be 27.9. MLN equals to 27.9 degrees. So we know that this angle is 27.9 degrees. Now we have to find out the length of HL, which is this length. Now the thing is, it's not a right angle triangle, so we can't apply sine, cos and tan on this, but we can take the whole big triangle. Okay, we can find out this whole length. Once we get the whole length, we can easily subtract this length from it to get this length. Okay, so first of all, I'm finding out NH. Okay, I'm not using Pythagoras theorem here. I'm insisting on using trigonometry only. So first of all, I have to see this right angle triangle, and I have to first find out NH. Okay, so I'm finding out NH first. Okay, so I'm going to use this angle, opposite and hypotenuse. I'm not using this because this I found it out. So the better idea is to use the one which the question has given already. So opposite upon hypotenuse. So I'm going to write sine of 38 equals to NH. I'm finding out NH, right? NH upon 9.2. Okay, so NH turns out to be 9.2 sine of 38. 5.66 centimeters. So this is 5.66 centimeters. Now I'm going to find out this whole length. Okay, because I know this angle, I don't know this whole angle, so I am just using this angle to find it out. So adjacent upon hypotenuse I'm using. Okay, cos of MLN or 27.9 equals to adjacent, which is NL, upon the hypotenuse, which is 15.5. Okay, so adjacent is NL and hypotenuse 15.5. So cos of 27.9 is this upon this. So NL turns out to be 15.5 cos of 27.9. Okay, 15.5 cos of 27.9. It's 13.698. So NL is 13.698. I can take more decimal places here also because this is not my final answer. So final answer has to be rounded off up to 3 significant figures for the length of HL. But intermediary answers you can take up to 2 or 3 decimal. That gives you more accuracy. Okay, now I know NL. I will write HL equals to NL minus NH. NL is 13.698 minus NH, which is 5.66. which is coming out to be 8.0. It's actually 8.0383, but I'm just rounding it up to 3 significant figures, 8.04 centimeters. So this is my answer for HL. Okay. Okay, I'm doing question number 5 then. In question number 5, they've told us that in triangle PQR, PQ is 17.4, okay, PR is 7.6, and Q lies on QR such that PKQ equals to 137. K lies on QR such that this angle is 137. Find QPK. First part you have to find out QPK. QPK is actually this angle, this whole angle you have to find it out. So if you look at this right angle triangle, you have this side and this side. So if you in case of a right angle triangle, if you have any two sides, you can use your knowledge of sine, cos and tan to get to the angle. Now since with respect to this angle, I have the adjacent and the hypotenuse, so adjacent and hypotenuse is cos, so I am going to write cos of QPK. Okay, they are asking for QPK. QPK is basically this angle, not the whole thing. QPK is this angle. But for finding out this angle, I will do what? I will first find out the whole angle. From that, I am calling that as x, for instance. From that, I will subtract this angle, which is this one. I will call that y, and that's how I am going to get QPK. Okay, so I am writing QPK is equals to QPK, angle QPK is equals to angle QPR minus angle KPR. That means this whole angle, which is QPR minus KPR, from this whole angle, if you subtract this angle, you will be left with QPK. Okay, so I am first finding out angle QPK. For QPR, I have to consider this whole right angle triangle. If I have to find out this whole angle, adjacent and hypotenuse are known, so I will use cos of QPR is equals to 7.6 upon 17.4. Okay, so I am doing cos inverse of 7.6 upon 17.4, 64.1. QPR is 64.1. Okay, once I found this whole angle out, I am writing x equals to 64.1. Now I am finding out angle KPR. Okay, so for KPR also I have to, okay, KPR, how can I find out angle KPR? If this angle is a 137, okay, that means if it's a straight line, this angle will be 180 minus 137, which is 43. So this is 43. Now if it's a right angle triangle and this is 90, this is 43, so this will be 90 minus 43, which is 47. So this is 47, we know, so I can write 47 here. Okay, so I'm writing angle KPR equals to 180 minus 90 plus 43, which is 47. Okay, so finally moving back to this statement, QPK, which we had to find out, QPK is equals to QPR minus KPR. QPR is 64.1 minus 47. It is 17.1. This angle is 17.1. Okay, degrees. Next part of the question, which is saying that you have to find out the length of QK. You have to find out the length of QK. In order to get to this length, first of all, I will find out this whole length, which is QR, and then I will find out KR and I will subtract them. I am calling this as, okay, so I am writing it down here. Okay, I'm writing qk is equals to qr minus kr. Okay, firstly I'm finding out qr. For finding out qr, I have to find out, I know this whole angle is 64.1, so opposite upon adjacent I'm using. Tan of 64.1 is opposite, which is qr upon pr. So I'm using tan of 64.1 equals to qr upon 7.6. So I'm finding out qr here. qr is 7.6 tan of 64.1. It's 15.65. So 15.65. Okay, then I'm finding out kr. For finding out kr, I have to use this angle, which is 47. So I have to use this right angle triangle, so this angle is 47. I can even use 43, so whatever. I'm using 47, opposite upon adjacent. Okay, so I'm writing tan of 47 equals to kr upon 7.6. So kr is 7.6 tan of 47. 7.6 tan of 47. This is giving me 8.15. kr is 8.15 centimeters. Okay, sorry, meters. Now I will write qk is equals to 15.65 minus 8.15. I'm using this statement, qr minus kr. 15.65 minus 8.15. It's giving me 7.50. 7.499, so it's 7.50. This is the answer for the last part of the question. Okay, so this is question number 5 done. Now we are doing question number 6, the advanced level question. The figure shows a triangle STU where TU is equals to 11. This whole length is 11. H lies on TU. Okay, so on TU such that the length TH equals to 120% of the length of HU. Okay, H lies on TU such that the length of TH is 120% of the length of HU. Okay, and SHU is equals to 90 degrees. Given that the area of STH equals to 21 centimeter square, find STSU. Okay, first of all, let's divide it in the ratio. They are saying that the length, if you notice here, length of TH is 120% of the length of HU. This is, if you take this as 100%, this is 120%. Okay, that means if I take this whole TH is 120% of the length of HU. Okay, and they've given us the area of STH after that. Okay, okay, if I divide this 11 into the ratios, okay, if I take this to be, this is 120% of this. If I take this to be x, this will be 120% of x. So if I write x plus 120% of x, okay, equals to 11. If I am taking this as x, this will be 120% of x. Okay, so add them up and make it equal to 11 and see what you get as x. I'm taking out the LCM. It will be 100x plus 120x equals to 11. So 220x equals to 1100. X equals to 1100 divided by 220. So 1100 divided by 220 is 5. X is 5. Now we know that HU is 5 centimeters. So obviously TH is going to be 11 minus 5, which is actually 6 centimeters. So this we know is 5 5 centimeters, and this we know is 6 centimeter. Now they are saying that given that the area of STH is this triangle, okay, the area of this triangle is 21 centimeter square. Okay, so area is half into base into height. Area is 21, base we know is 6 centimeter of this triangle. We're talking about this triangle. We can easily find out SH now. Height is SH. Okay, I'm finding out SH by simplifying first of all. 3 times SH equals to 21. So SH equals to 21 upon 3, which is 7 centimeters. This is 7 centimeters. Find TSU. You're supposed to find out TSU. You're supposed to find out this whole angle there. Okay. I can easily find this angle first and this angle then, and then add them up to get the overall angle. So, yeah. So I'm just simply calling this as finding. I can write TSU equals to TSH plus HSU. Okay, firstly I'll find out TSH. So I'm giving this heading, I'm finding it out. In order to find out TSH, I know the opposite, I know the adjacent. Okay, so I'm going to use tan. Tan of TSH equals to opposite upon adjacent. So tan inverse of 6 upon 7, which is giving me 40.6. So TSH equals to 40.6. Then I'm going to find out HSU. If you look at this angle, the opposite is 5 and the adjacent is 7. So I'm going to use tan again. I'm going to write tan of HSU equals to opposite upon adjacent, tan inverse of 5 upon 7, 35.5. So HSU equals to 35.5 degrees. So I simply have to, for TSU, which is the whole big angle, I have to add this, which is 40.6, and this is which is 35. This is 40.6 and this is 35.5. I am adding them up together. 40.6 plus 35.5. It's coming out to be 76.1, because I have to give the answer up to 1 decimal to 76.1 degrees. So the final answer is 76.1. This is the final answer. Okay. Then we move on to question number 7. It says the figure shows a trapezium. The figure shows a trapezium WXYZ, in which WX is parallel to ZY. It is given that WX equals to 4.7, ZY equals to 7.8. This whole length is 7.8. WZY is 62 degrees. K lies on ZY such that the ratio of the length of WK to the length of ZY, WK to the length of ZY is 6:13. Okay, find angle XYZ. Okay, and the parameter of the trapezium WXYZ. Okay, so they've given us the ratio. Okay. It says K lies on ZY such that the ratio of the length of WK to the length of ZY. Okay, fine. So WK ratio ZY, they are saying is 6:13. But we know these are the ratios, okay? But the actual length of ZY is known to us, which is 7.8. So I'm picking it up from here. The overall length is 7.8. This is the actual length. Now you have to always check in case of ratio, if you know ratios, how to solve it. If this is a ratio and this is the actual length, 13 multiplied by what gives you 7.8? 13 multiplied by 0.6 according to me. 13 into 0.6 gives us 7.8. Okay. So we are multiplying 13 by 7.8, sorry, 0.6 to get 7.8. So you have to multiply 6 also by 0.6, which is 3.6. So that means the length of WK is 3.6. Once you get the length of WK, Okay, it's just like the simple concept of ratio, where if I say the ratio of boys to girls is 1:2 in a class, this does not mean that there's just one boy in a class and there are two girls in the class. This is the ratio. Now if I say that the girls in the class is say 18, so this was the ratio, and this is the actual number of girls in the class. Ratio multiplied by what number gives you the actual? So 2 multiplied by 9 is 18, so 1 multiplied by 9 will give you the number of boys. So, and you will notice that when you simplify this, you will get 1:2 only. Okay, so these are the actual numbers, these are the ratios. Likewise, we had 6:13 was the ratio, and this actual length, which is zy, is 7.8. So we had to see 13 multiplied by what is 7.8. 13 multiplied by 0.6, so 6 multiplied by 0.6 will give you 3.6. So now we know that this is WK is 3.6. They are saying find out angle XYZ. You're supposed to find out, if that is 3.6, obviously this is also 3.6. Okay. Now, we have to find out, can we find out this side, ZK? Because see, if I want to find out this angle, I have to have another side of this triangle. I'm talking about this triangle, okay? I need to have another side of this triangle. I just know that this is 3.6. So I can actually find out this side very easily if I find out this measurement. If I know this measurement from 7.8, if I subtract this measurement, I'll be left with this whole measurement, and this is 4.7. 7.8 minus this is going to give me this measurement. Okay, so right now I'm finding out ZK. Okay, so since I have an angle on one side, I can find out this side, which is opposite upon adjacent. So I'm using tan of 62 equals to 3.6 upon ZK. So ZK turns out to be 3.6 upon tan of 62. 1.91. ZK is 1.91 meters. Okay, now I can easily find out, this I know is 4.7 from here till here. Okay, and this is 1.91 from here till here, it's 1.91. So I can find out, if I call this as, I can use another alphabet, for instance P here. So I can write Py is equals to Zy minus ZK minus Kp. Okay, Kp. Fine. Zy is 7.8, Zk is 1.91, and Kp is 4.7. So I'm subtracting. It's coming out to be 1.185. So Py is 1.185. Now that I have these two sides of this right angles opposite and adjacent, I can easily find out this angle. So I can find out angle XYZ now. Tan of XYZ equals to opposite, which is 3.6, upon adjacent, which is 1.185, 71.8. So XYZ equals to, with rounding off, 71.8 degrees. Then in the next part, they are asking for the parameter of the trapezium WXYZ. So you have to find out this length and this length. The rest of the lengths are with us, 4.7 and 7.8. I can easily find out this length. Okay, so I'm finding out WZ. I'm using the same figure. Okay, in order to find out the parameter of trapezium comprises of WZ plus XY plus 4.7 plus 7.8. Okay, so 4.7 and 7.8 is already known to us. We have to find out WC. So I'm finding out WZ firstly. Okay, opposite upon hypotenuse. I know this with reference to this triangle. Opposite is 7.6, hypotenuse I want to find out. Sine of 62 equals to 3.6 upon WZ. So WZ will be 3.6 upon sine of 62 degrees. .08. WZ will be 4.0877, so it's 0 I can take more decimal places here. 077. Okay, now I have to find out xy. I already know this angle, which is 71.8. I'm writing this angle here, 71.8. So I can use opposite upon hypotenuse or adjacent. I'm using opposite. Sine of 71.8 equals to opposite, which is 3.6 upon xy. So 3.6 equals, sorry, xy is equals to 3.6 upon sine of 71.8. xy is turning out to be 3.79 or 789. Okay, meters. So perimeter would be 4.077 plus 3.789 plus the rest of the two measurements which are already known to us, 4.7 and 7.8. I'm just adding them up together. It's giving me perimeter equals to 20.366. So I'm writing it up to three significant figures, 20.6 meters. This is the answer for this part of the question. So we are done with almost, just the last question is left. We can do the last question also very quickly, the 8th one. The figure shows the triangle ABC where angle ABC equals to 35 degrees. H lies on BC. H lies on BC such that the length of AC is twice that of BH. This is x and this is 2x. Find angle ACB. You're supposed to find out this angle. Okay. Now, in order to find out angle ACB, first of all, if I can find out AH, because if I want to find out this angle, I need at least two sides of this. One side is in terms of x. I can find out this side also in terms of x. Okay, first of all, I'm going to look at this triangle because here I have the angle and a side. I can find out the opposite angle. I have this, I don't have a particular number as far as this measurement is concerned, but I have it in terms of x. So I can use tan here. Tan of 35 is AH upon x. Tan of 35 equals to AH upon x. So I can make AH the subject, it will become x tan of 35. So that means AH is x tan of 35 degrees. Okay, now I have the opposite side and the adjacent side. I can easily use tan to find out this angle. So I'm going to write tan of angle ACB equals to opposite, which is x tan of 35. Okay, so I'm taking this measurement upon this, opposite upon adjacent, upon 2x. X and x will simplify. Tan of ACB is equals to tan of 35 upon 2. So I'm using the calculator. I'm writing tan of 35 divided by 2. It's giving me 0. Tan of ACB equals to 0.35. Now in order to get ACB, I will do tan inverse of 0.35. Okay, tan inverse of the answer, it's giving me 19.29. So round off up to one decimal place because it's an angle. ACB is equals to 19.3 degrees. So we are done with this whole exercise. In this exercise we learned how to find out the unknown angles and then we practiced finding out the unknown sides also. So that's the end of the class. In the next class we'll move on to doing the word problems of trigonometry. Thanks a lot for watching this video.